Hello everyone, welcome back to Startup Academy, your online gateway to ISS exam. Today in this lecture, we will discuss further about statistics paper 3, which is descriptive, and we were discussing the topic econometrics. In the previous lecture, we have discussed simple linear regression and simple linear regression model and all about its estimation and the properties of the estimators, and we have discussed one question which came in 2020. In today's lecture, we will be covering the topic multiple linear regression model, which is in the continuance of simple linear regression model. So let's start. Multiple linear regression model. Suppose that in simple linear regression model, we only had one model which contained only one values of x, y, and epsilon, which is error term. Suppose that we have n values of y1, y2, up till yn, and n values of x11, x21, up till xp1, x12, x22, up till xp2, and so on up till x1n, x2n, up till xpn. And the values of the parameters are also beta 1, beta 2, up till beta p. Plus, we have the error term also epsilon 1, epsilon 2, up till epsilon, sorry, epsilon n. So we have got this. Now we have to solve this model. This model has so many terms. In the earlier model, simple linear regression model, we had only one x, one y, and two parameters beta naught and beta 1, and one epsilon or error term. But in this we have multiple n numbers of these terms. So how will we solve this? We will solve this by matrix method. So we will take the matrix of these values. This matrix is of n cross 1. This matrix is of n, n cross p. This is of p cross 1. And this is again of n cross 1. So our model becomes y, capital Y is equals to x beta plus epsilon. This becomes our multiple linear regression model, where the value of y is n cross 1, of x is n cross p, of beta is p cross 1, and of epsilon I is n cross 1 respectively. Now, again, we will see some assumptions which are Gauss-Markov assumptions in this as well. So what does Gauss-Markov assumption says? First of all, that data should be randomly selected. Obviously, when we are talking about statistics, then data should be randomly selected. The second one is bi-i's should be linear, or this property is known as linearity. Then the third one is estimation of epsilon I is equals to 0 for all I goes from 1 to small n. Then variance of epsilon I should be a constant value sigma square, but it should also be multiplied with an identity matrix In, because we are talking of matrix in this for all I goes from 1 to n. Next is covariance between epsilon I and epsilon j is equal to 0 for all I not equal to j goes from 1 to n. Now in this variance, this property is known as homoscedasticity. And this property is known as no auto correlation. Then again, the sixth property is no endogeneity. Which means that epsilon I and covariance of epsilon I and xi should be equal to 0. That is, error term should not depend on independent variable. Now the seventh one is no multicollinearity. The multicollinearity means that neither of the xi should be depend on each other, which means covariance of xi and xj should always be equal to 0. These are the 7 assumptions which we did in simple linear regression model as well, and here also the assumptions remain the same. Now we will take the model. We will be doing estimation. Estimation of the model. Model is given as y is equals to x beta plus epsilon, where y is n cross 1, x is n cross p, beta is p cross 1, and this epsilon is n cross 1 respectively. Now again in this, like we took the method of least square in the simple linear regression model, here the method is known as OLSE, ordinary least square estimation. This is known as ordinary least square estimation. So here again we will take E as summation I goes from 1 to n epsilon I whole square, which can be written as epsilon I dash into epsilon I. Since epsilon I dash is the transpose of epsilon I, we can write it as y minus x beta dash into y minus x beta. Then this can be written as taking the transpose inside minus beta dash x dash into y minus x beta. Here the transpose of AB is equals to B dash A dash. This is the property of a matrix. So multiplying these two terms, we get y dash y minus y dash x beta minus y beta dash x dash plus beta dash x dash x beta. This will be the value of E. Now we will differentiate it with respect to beta. Then we will get y dash differentiation of y dash y as 0 and minus 2 x dash y plus 2 beta x dash x. Now putting this normal equation equal to 0, we will get 2x dash y is equals to 2 beta x dash x. Here 2 and 2 gets cancelled and we will get the estimator of beta as beta cap is equals to x dash x inverse into x dash y. This is the estimator of beta cap. So in this again we will find the properties of beta cap. First property, unbiasedness. So the property of unbiasedness says estimation of beta cap is equals to estimation of x dash x inverse x dash y. Since x is independent variable, it will come outside of estimation and only y will be under estimation. X dash x inverse into x dash will come out and we are left with estimation of y. Now we can write it as x dash x inverse x dash, estimation of y can be written as estimation of x beta plus epsilon. Here again x beta are treated as independent variables, so we can take out estimation of that and we are only left with x dash x inverse x dash x beta plus estimation of epsilon. Now again, in Gauss-Markov theorem, we have studied that estimation of epsilon I is equals to 0, which is the error term. So from here, this will become 0 and our term will be x dash x inverse x dash x beta. Now here, these two terms, x dash x inverse and x dash x. Inverse multiplied by the number gets cancelled and we are left with beta. And hence we can say that beta cap is an unbiased estimator of beta. Now moving on to the second property, which is variance of beta cap. Variance of beta cap can be written as variance of x dash x inverse x dash y. Now we know that variance of a dash b can be written as a variance of b into a dash. Similarly, proceeding with this, we get A into B. Proceeding with that formula, we will get x dash x inverse x dash variance of y into x x dash x inverse. Now we know that that transpose of an inverse is equals to that inverse only. So here we have taken the inverse directly. Now variance of y, since variance of epsilon I is equals to sigma square in, which is equals to variance of y. Now putting the values here, x dash x inverse into x dash sigma square in x x dash x inverse. Taking the common digit outside, sigma square in is nothing but a multiplication of identity matrix, so it will dissolve in this. We are left with x dash x inverse x dash x x dash x inverse. One x dash x inverse and one x dash x gets cancelled, and we are left with variance of beta cap is equals to sigma square x dash x inverse. This is the variance of our beta cap estimator. So now we will discuss one question, which is PYQ, regarding the topic we have done. This PYQ was given in 2025 recently in the examination, and it was of 15 marks as stated. So the question says that we have been given a model x beta plus u, where u is the error term and estimation of u is 0, and estimation of u dash u, which is the variance of u, is equals to sigma square in. Now first we have to derive the OLSC, that is ordinary least square estimator of beta, and its variance covariance matrix. As we have done earlier the properties of beta cap, similarly we will proceed in this one. And the second one is give unbiased point prediction and obtain its variance. So let us start doing this. First we are solving for first part. Now our model is given as y is equals to x beta plus u, where y is n cross 1, x is n cross p, beta is p cross 1, and u is n cross 1. As we will proceed, we will see that by OLSC, which is ordinary least square estimation method, we will get E is equals to summation I goes from 1 to n ui whole square. Now this can be written as u dash u. Because we are talking about matrix, so all the i's are contained in u, which further can be written as y minus x beta dash into y minus x beta. Now taking in the transpose, we will get y dash minus beta dash x dash into y minus x beta. Now multiplying both the terms, we will get y dash y minus beta dash x dash y minus y x beta y dash x beta plus beta dash x beta. On differentiating this E with respect to beta, since we are calculating the estimator of beta, then the normal equation comes out to be 0 plus 0 minus 2 x dash y plus 2 beta x dash x, which is equals to 0. Now putting it equals to 0, we will get x dash y beta x dash x is equals to x dash y. Now multiplying by x dash x inverse on both the side. Here these two terms get cancelled and we are left with the estimator of beta, which is x dash x inverse into x dash y. This is the OLSC, which is ordinary least square estimator of beta. Now they have asked in the question, derive the OLSC of beta, which we have done, and its variance covariance matrix. So the variance covariance matrix can be written as variance of beta cap, which is nothing but variance of x dash x inverse into x dash y. Here again we will use the property of variance of ax as a variance of x into a dash. Using this property, we will get x dash x inverse x dash variance of y x x dash x inverse. Since the transpose of inverse is always the inverse, so we have taken the inverse directly here. Now variance of y. We know that variance of ui is equals to sigma square in, variance of u, which is given in the question, which is also equal to variance of y. So substituting this in the above equation, we will get x dash x inverse x dash sigma square in x x dash x inverse. Now taking the common term outside, sigma square, in gets dissolved because it is identity matrix. So x dash x inverse x dash x x dash x inverse. These two terms will get cancelled and we are left with variance of beta cap is equals to sigma square x dash x inverse. This is the value of our variance, covariance matrix. So the next question says that give the unbiased point prediction and obtain its variance. So what are point predictions? We are talking here. We have talked about the matrix. If we have to talk only about a point, let us consider we are doing second one.